Welcome to homework.
We want to find all the zeros real and complex, stating the multiplicity of each zero and write a complete factorization. In part A, let's go straight away to a calculator to see what we can find. We have x to the fourth plus 2x squared plus 1. And so we have zero real solutions. And since we have zero real solutions, we can just try to factor x to the fourth plus 2x squared plus 1. It does look to be a perfect square in that x squared plus 1 times x squared plus 1, right? That would give you x to the fourth plus x squared is 2x squared plus 1. Or we can just say that this is x squared plus 1 squared. That's the factored form. The zeros then would be when x squared plus 1 is equal to 0. That would be when x squared is equal to negative 1. And this would be when x is equal to the positive and negative square root of negative 1, which would be positive and negative I. And so we would have a solution of negative I and I, both multiplicity 2. And we already have the factored form. Let's take a look at p of x equals x cubed plus 2x squared plus 4x plus 8. X cubed plus 2x squared plus 4x plus 8 has a real zero at negative 2. That would be multiplicity 1. Let me zoom out to make sure that's all. It is. We can synthetically divide negative 2 from our coefficients. We should expect a remainder of 0. Drop down the 1, multiply, add, multiply, add, multiply, add. Sure enough, we do. And so we have x squared plus 4 is equal to 0 to help us find the others. That would mean x squared is equal to negative 4, and x is the positive negative square root of negative 4, which is positive and negative 2i. So another solution would be negative 2i and positive 2i, each multiplicity 1. In factored form, we could take that x squared plus 4 and then times x minus 2, the real one. Now we want to find all the real zeros of p of x equals x cubed minus 3x squared minus 4x plus 12. You can say that they're negative 2, positive 2, and 3. Therefore, in factored form, that would be x plus 2 times x minus 2 times x minus 3. And since 0, 12 goes through this, we don't need a scalar.